A cone is a solid body that has only one edge, and that is circular edge at base, and it has only one corner, that is its apex. A cone doesn't have sharp corners at the base, and it doesn't have base edges. In front view, when it is resting on HP on its base with axis vertical, then in front view it appears an isosceles triangle, and in the top view it appears a circle. Apex in the top view coincides with the center of the circle. Before we start solving problems on cones, sections of cones, you must know about conics. Listen carefully. Circles, ellipse, hyperbolas and parabolas are curves can be obtained by cutting a cone. That is why these curves are known as conics. When a cutting plane is parallel to base of a cone, that is angle made by cutting plane, this phi is angle made by cutting plane with the base. When angle made by cutting plane with the base is 0, that is cutting plane parallel to base, then the section is a circle. When angle made by cutting plane with the base is the same as angle made by generators with the base, in other words, in front view, when cutting plane line is parallel to end generator, then the section we get is a parabola. When angle made by cutting plane with the base is less than angle made by generators, then corresponding section is an ellipse. And when angle made by cutting plane with the base is more than angle made by end generators with the base, then it is hyperbola. One more thing, if cutting plane appears in the top view, when cutting plane appears in the top view, that is when cutting plane is a perpendicular to HP, then we are sure that section is hyperbola, because in that case angle of cutting plane with the base of the cone is greater than angle of generators of the cone. This is very important to understand. You may face a problem in which you will be asked to locate cutting plane for the given particular shape of a section. Okay, let's start with problems. A cone of base diameter 60 mm and axis 65 mm is resting on HP with its axis vertical. In this position, it is cut by an AIP. AIP, full form is auxiliary inclined plane. A plane which is inclined to HP and perpendicular to VP is called an AIP, auxiliary inclined plane. So it is clear here, that is the plane is inclined to HP but perpendicular to VP. This suggests you, when cutting plane is an AIP, it suggests you that the cutting plane line is in front view. Okay, the cutting plane cuts axis of the solid 30 mm above the base. Draw sectional front view, sectional top view, sectional side view and true shape of the section. So as usual, we should start with views of object in given position. That is very first step. So as usual, here it is XY line, label HP, VP and check where true shape of base must be. So in this case, it's clearly given axis is vertical, that is perpendicular to HP. So true shape of base should be in HP. So first of all, locate center by drawing a vertical and a horizontal center line, and then draw a circle of radius 30 mm because diameter of the base is 60 mm. This is true shape of base. Now note here, there are no sharp corners at the base. To continue with the projections of the cone, we need some reference points on the base circle. So we mark either 8 equidistant points on the circle or 12 equidistant points on the circle. Let's mark 8 equidistant points on the circle. So use a protractor, measure 45 degrees and mark the points. At an angle 45 degrees, draw 2 more diameters of the circle. So this is how we have divided this circle in 8 equal parts. Now these are the points going to help you to project the cone in other views. Label these points. So as usual, we have labeled these points in alphabetical order using letters. Now transfer these points in the front view. So as usual, we have assumed entire base in HP, and that is why front view of all these points be on XY line. Now measure height of the cone. Height of the cone. Length of axis is nothing but height of the cone. It is to be measured vertically upwards. And locate apex. Draw projector from apex in the top view. And this is how you have located apex. Now join apex with all base corners. So O dash A dash, O dash B dash, O dash C dash, O dash D dash, E dash. So this is how we have drawn all 8 generators in the front view also. Remember, generators are not edges. You must not make a generators dark. In views of a cone, only boundary of the cone must be dark. Only boundary must be dark. Remember, only boundary must be dark. But again, we are solving problems on sections. So unless we cut the object, we must not make a boundary of retained portion dark, because we don't know which is the retained portion. So let's proceed. Check whether sectional side view is. So sectional side view is asked. So we'll complete the sectional side view also. So as usual, by drawing projectors from top view to side view and front view to side view, get all 8 plus 1 points, that is 8 points on the base circle and apex in the side view, and complete the side view. Join apex with all base corners. Remember, there must be all 8 generators in all the views. Without that, you will not able to complete the drawing. Okay, so this is first step is over. Here is a cone in given position, and now we'll locate the cutting plane. Read the information about the cutting plane. In this position, it is cut by an AIP. AIP, as I've already told you, it is plane perpendicular to VP and inclined to HP. So it is clear that plane is perpendicular to VP, and therefore the cutting plane line must be in the front view. It is inclined to HB by 40 degrees. So this cutting plane line we are going to draw at an angle 40 degrees. And the cutting plane cuts the axis of the solid 30 millimeters above the base. So on the axis 30 millimeters from base, we are going to mark a point. So measure 30 millimeters vertically and get that point on the axis 30 millimeters from base. Now through this point at an angle 40 degrees, draw the cutting plane. Now cutting plane is like an axis, longer dash, shorter dash, with end dashes dark. So this is how we have completed the cutting plane. There are clearly 2 parts of the object. The portion which is nearer to observer is removed portion, and portion which is nearer to XY line is retained portion. So I have made a retained portion dark. But I have made retained portion dark doesn't mean that I have made all generators dark. As I have told you, in case of cones and also in case of cylinders, we should make only boundary dark. Then there are no face edges, but we have used generators. So where cutting plane line intersects generators, label those points with extra letter P. So PA, it is point of intersection of cutting plane line and generator OA. Similarly, PB and PH, PC and PG, PD and PF, PD and PF, they are coinciding of course, because there are 2 edges here, OD and OF. So PD and PF are on generators OD and OF respectively, and at boundary generator OE, and PE is on generator OE. Now remember, when cutting plane intersects a sharp edge of an object, a corner of a section gets created. In case of cones, these P points are not sharp corners. One more thing, here angle made by cutting plane line with the base is less than angle made by generators, and therefore we are sure that the section is an ellipse. So that section, that is the ellipse, we are going to draw in the top view and also in the side view. As usual, transfer all these P points in the top view on corresponding generators and in the side view on corresponding generators. So this is how I have transferred these points. PA is on edge OA, PB is on edge, not edge of course, here it is generator, PH is on generator OH, PD is on generator OD, and this is how I have transferred all the points. But what about points PC and PG? In case of pyramids, in our earlier video, we have studied that if an edge appears vertical in the front view, then to transfer the points on that edge, we will have to use a proper procedure. It's the same procedure we are going to follow here. Check. PC on end generator, then on the same generator OA, and by drawing arcs here on respective generator. So PC is on edge OC and PG is on generator OG. And this is how we got points PC and PG also in the top view. Now here, one more thing I'll tell you here. PC and PG we have transferred from front view to top view. Otherwise, we can take PC and PG in the top view from side view also. Check here. PC and PG you transfer from side view to top view. So here it is point PC and here it is point PG. So this is how we can transfer PC and PG from side view to top view. But here one thing students should understand, that always side view will not be there to help you. If side view is not asked, we should not draw side view. But in that case, to transfer PC and PG, you will have to use the procedure which we have studied already, that is transfer these points on boundary generator and then on corresponding boundary generator in the top view, and then by drawing arcs from center of the, that is apex in the top view, you can transfer these points on corresponding projectors. Okay, then as I told you that these P points are not sharp corners and therefore we should not join these points by straight lines. Second thing, since it is a cone and angle made by cutting plane is less than angle made by generators with the base, and therefore we were knowing already that corresponding section is an ellipse. Just draw ellipse by joining all these points. It is a section that is newly generated surface, so draw hatching lines. Now to draw true shape of the base, to draw true shape of the section, we should make cutting plane line, which is right now in front view, cutting plane line parallel to XY line. So make this line parallel to XY line, transfer all these points exactly using the same distances, so use compass for the purpose, and this is how the cutting plane line with all P points we have made parallel to XY line. And then as usual, front view to top view vertical projectors, and from adjacent top view horizontal projectors will able to complete the true shape of the section, which is an ellipse. This is final drawing. Remember, all given dimensions, that is height of the cone, length of axis, diameter of base of the cone, location of cutting plane, 30 mm above the base, inclination of cutting plane, all these given dimensions you must insert in the drawing. Now let's solve this problem. A cone of base diameter 60 mm and height 70 mm is resting on HP with its axis vertical. It is cut by an AIP parallel to generator of the cone and 12 mm away from it. Draw sectional front view, sectional top view, sectional side view, and true shape of the section. Watch here. Once again, here we got the cone, a cone with axis vertical. So let's draw views of the cone. So as usual, top view, because axis is vertical or perpendicular to HP, true shape of base is circle in the top view. We have divided circle in 8 parts. All generators, that OA, OB, OC, OD, OE, all 8 generators. Of course, there are infinite generators a cone has. Out of those infinite generators, 8 generators we are going to use to solve the problem. So these 8 generators in the front view and in the side view also you must be able to draw. Once you have completed views of the object in given position, second important step is to locate the cutting plane. It is cut by an AIP. What is this AIP? A plane perpendicular to VP and inclined to HP. So very important, it is perpendicular to VP and therefore true shape or that line view of the cutting plane will be in the front view. It is cut by an AIP parallel to a generator of the cone and 12 mm away from it. Okay, so how to draw this cutting plane line? Try to understand. Cutting plane line is a parallel to generator. Only end generator shows its true inclination, and therefore we should draw cutting plane line parallel to end generator at distance 12 mm. Now here I have seen many students making mistake in measuring that distance 12 millimeters. Distance of cutting plane line from the end generator, that is nothing but, in our drawing it is distance between two lines, two parallel lines. So distance between two parallel lines must be its perpendicular distance. So measure 12 millimeters perpendicular to the boundary generator. So this is how you are going to draw that cutting plane line, which is 12 millimeters from the end generator. So this is how we should measure that 12 millimeter distance. Now this is how we have drawn that 12 millimeter line parallel to end generator. Then transfer these points. Label the points of intersection of cutting plane and the generators. So PA, PB, PH, and immediately transfer these points also in the top view on corresponding generators. Now watch here. In this case, cutting plane intersects base. So there are 2 points on the base. I've told you earlier, when cutting plane intersects base, it creates 2 points on the base edges. So here also on the base circle, there are 2 points, U and V. So transfer these 2 points, U and V, on the base circle and not on any other generators. So points of intersection of cutting plane line and generators, you should label with extra letter P. And U and V are points on the base circular edge. Remember I told you, when cutting plane intersects an edge, a sharp edge, it creates a corner. So U and V are sharp corners. But these points, which are labeled with letter P, are not sharp corners because these points are on curved surface of the cone. These points are not on sharp edges. Okay. So as usual, PC and PG, you take it on boundary generator first, then project it on corresponding generator in the top view, and finally, using compass with center as O, transfer these points back to their own projectors. Now, transfer all these points in the side view also. Check here, U and V also we have transferred from top view to side view. Get all those points in the side view. Unless you have transferred all those points on the side view, don't try to draw section. Let's proceed. So this is that parabola we have studied earlier in the same video. That is, when cutting plane line is parallel to its boundary generator, then section is a parabola. So we have completed that section in the parabola in the top view and in the side view. Remember, U and V are sharp corners and UV is always a straight line. So parabola, all P points we have joined with a curve, but U and V we have joined with a straight line, and that is a line on the base. Now let's make retained portion dark. Once again I'm telling you, don't make any other generator dark. On the retained side, make only boundary dark. Now watch here. UV, on the right side of UV, it is retained portion. So top view, here it is UV. So on the right side of UV, make retained portion dark. But once again, only boundary, don't make generators dark. In the side view also, it's same thing. Apex portion is removed, lower portion is retained, but only boundary of the lower portion you make dark. And of course, section is a surface, it is newly generated surface, so a section must have a closed boundary. So here it is retained portion we are making dark. And this is how it is final drawing. To draw true shape, like all earlier problems, make cutting plane line parallel to XY line, transfer all these points using compass on the parallel cutting plane, and you will get true shape of the section. Okay, so true shape of the section is a parabola. This distance UV is known as base of the parabola, and length along axis of symmetry of the parabola, that is axis of the parabola. Length of the base of parabola appears in the top view. It is UV. This length is directly getting transferred to the true shape. So remember this, length of base of parabola appears in the top view as line UV. And axis, watch here, axis, this is a true shape of the section. That is, this is true length of the axis from point PA, the horizontal line, up to base of the parabola. That is length of the axis. This length of the axis is here in the front view, PA to UV, from PA dash to U dash V dash. And note here, that is this length we have taken directly from front view. So remember this, it will help you to solve some other problem. That is, true length of base of the parabola appears in the true shape of base as line UV, and true length of axis of parabola appears in front view, and that is parallel to boundary generator. In this problem, just now we have discussed about base and the axis is not significant, but in some other problem, it will help you. Let's solve next problem. Read this problem. Excuse me. A cone base diameter 70 mm and slant height 75 mm is resting on HP with its axis vertical. In this position, it is cut by an AVP. In earlier two problem, it was AIP. In this case, it is AVP. AVP is auxiliary vertical plane. Listen carefully. Auxiliary vertical plane. So one thing is clear, that the plane is vertical plane. That means cutting plane line appears in the top view. So we are going to draw cutting plane line in the top view. Okay. It is inclined to VP by 30 degrees. It is inclined to VP by 30 degrees. So we are going to draw that cutting line at an angle 30 degrees. But infinite lines we can draw in the top view. So where exactly that cutting plane line is? The cutting plane is 15 millimeters away from the axis, and it is nearer to the observer. Okay. So first of all, check where is axis in the top view. So this point O is axis in the top view. Axis appears a point in the top view. So we are going to draw a cutting plane line at a distance 15 millimeters from point O. One more very important thing in this problem. In all earlier problems we solved, including video 1, it was axis given in each problem. Axis or height of the object was given in all those solved problems. But in this case, it is slant height given. Slant height of a cone, that is height of the cone measured along its inclined surface. So slant height, when it is given, how to mark apex, that's very important. Now listen, from apex, first you should draw a projector vertically, and along that projector, don't measure vertically 75 millimeters. Take 75 millimeter in compass and cut the center line to get that point O dash, so that this length O dash E dash is 75. So this is one very important thing in this problem. Otherwise there will be mistake at very first step only. So take care of that. Now let's focus on the cutting plane line. Draw a circle of radius 15 millimeter. What is logic behind that? Now any line which is drawn tangent to the circle will be at distance 15 millimeters from axis or from point O. That is why with 15 millimeter radius we have drawn this circle. Now cutting plane line we are going to draw tangent to the circle at an angle 30 degrees. Cutting plane line must not be closer to XY line, but it should be always closer to the observer, so that larger portion gets retained and smaller portion gets removed. So now we are ready to draw a cutting plane line at an angle 30 degrees. Try to understand how to draw that cutting plane line. Anywhere on the plane you draw a 30 degrees line, 30 degrees with XY line. Set roller with that line. Roll the roller to draw the required tangent to the circle. And this is a cutting plane line. Of course, you should draw the cutting plane line, a longer dash, shorter dash, a chain line with end dashes dark. So here, cutting plane line in proper position. So two important steps in problems on sections of solids: position of object and position of cutting plane. These two steps are over. So now there is no really possibility of mistakes. Lekin, try to understand here something new now. As usual, first we'll label line of points of intersection of cutting plane line and generators of the cone. PE, OE is generator, PF on generator OF, PG on generator OG, and this cutting plane cuts the base. So we must have 2 points on the base, U and V. So this is how here it is point U and here it is point V. And now of course we are going to transfer all these points in the front view and in the side view. So we'll get a hyperbola. How come hyperbola? I have explained you earlier. When angle made by cutting plane with the base is greater than angle made by generators with the base, then the section we get is hyperbola. So that hyperbola we'll get here in the front view and also in the side view. But now very important thing here, cutting plane line is in the top view. Height of the object doesn't appear in the top view. We always get height in the front view. But in case of hyperbola, it's very important to get the highest point, and that is nothing but a vertex of the hyperbola. So which point is the highest point? Height doesn't appear in the top view, then how to locate that highest point? So try to understand. This is really something new here. What logic we are going to use here to locate the highest point? Try to understand. Even if height doesn't appear in the top view, we can say that the point on the cutting plane line which is nearest to the apex is highest point. So how to locate that point on the cutting plane and nearest to the apex? Now this is also, you know, that shortest distance between a point and a line is its perpendicular distance. So here in such problems we'll have to draw an extra generator. Now try to understand, generator OA, generator OB, 8 generators we have already drawn, and one more generator is required, and this generator must be perpendicular to the cutting plane line. So how to draw that generator? Try to understand. Use protractor. Axis of symmetry of protractor, set it with the cutting plane line, and straight edge of the protractor set it with point O, and draw a line. This is that extra generator. Now label that point on the base edge as M. So like generator OB, generator OB and those 8 earlier generators, OM is also a generator of the cone. Now this generator we must have, like all other 8 generators, we need a generator OM in the front view as well as in the side view. So as usual, project point M in the front view and in the side view. Let's do that. So here it is M dash and here it is M double dash. Now join O and M in the front view and also in the side view. So this blue colored generator in the front view and a blue colored generator in the side view are these are the views of that extra generator OM. And like all other points of intersection, I marked this point PM also. Point PM is on the cutting plane and on that extra generator OM. What is the significance of point PM? This is the highest point on the hyperbola. This is vertex of the hyperbola, and for this purpose this extra generator we have constructed. Now remember, only in case of a cone, when cutting plane line appears, only in case of cones when cutting plane line appears on true shape of base view, you will require that extra generator. So earlier problems we solved on pyramids or some other problems on prisms and cylinders we are going to solve. In such problems, extra generator is not required. Only in case of cones. Listen to me very carefully. When cutting plane line is on true shape of base of the cone, then the extra generator is required. Now second important thing, you listen to me very carefully. Sometimes it is possible that one of the earlier 8 generators is perpendicular to the cutting plane line. Have you understood? It is possible that there is already a generator available perpendicular to the cutting plane line. In that case, this extra generator is not required. For example, had it been a cutting plane at an angle 45 degrees, listen to me very carefully, had it been a cutting plane inclined at an angle 45 degrees, then we would have got that edge OF or generator OF perpendicular to the cutting plane line. So remember, it is possible that in some of the problems on cones, you may have a generator out of these 8 generators, a generator perpendicular to the cutting plane line, then no extra construction is required using extra generator. Okay, now let's proceed. Remaining work is similar to all other problems. Try to understand. Transfer all these points in the front view and in the side view. So initially I've transferred that highest point PM front view and PM in the side view. Now watch here, PM is on edge OM. Obviously PM is on generator OM, not edge of course, generator OM. So obviously this PM in front view on generator OM, in side view on generator OM. Similarly all points U and V are on the base. So u and v will appear on the base in the front view and also in the side view. U point, then PE dash, then PF dash, then PM dash. Already we have transferred. Now PG, check how we have transferred it. Have you understood the procedure? Generator or an edge, if it appears vertical in front view or in the top view, then this is that procedure you are going to follow to locate that point in the opposite side view. So we have transferred all these points in the front view. Join these points by smooth curve. As I've told you earlier, UV is always a straight line on the base. And remember, we were knowing already that section is a parabola. So join all P points by smooth curve. It's not parabola, of course, it's hyperbola. So let's continue. Transfer all these points in the side view. And join these points. Check here, U point and V point on the base. UV is a straight line. This V point is actually here. Press this red line and here it is point V. So this is how we have completed that hyperbola in the front view and in the side view. Now we'll have to make a retained portion dark. Let's make retained portion dark. The view in which the cutting line is, that view gives you clear idea about the retained portion and removed portion. Portion which is nearer to observer is removed portion, and portion which is nearer to XY line is retained portion. And in case of cones, we must not make generators dark, only boundary. So this is how we have made retained portion in the top view dark. Check here, apex is on the retained side. So here it is a retained portion. In the side view, check here, this is front side, this is back side. So back side of the section, remember this is front side, this is back side, this is top side and this is bottom side. So this portion is retained portion, and check here, this is front side, it is removed. Check, G is on the front and G portion is on the removed side. So this portion of the cone is removed. So this is how sectional top view, sectional front view, sectional side view are complete. Now this newly generated surface, that is section, we should draw hatching line on this portion. So three views of retained portion of the cone are ready. Now for true shape of the section, in this problem, cutting plane line is in the top view. Make this line parallel to XY line. It means top view is parallel, and when top view is parallel, front view gives true shape. Let's do that. So this is how I've drawn the cutting plane line. Now use compass to transfer all these points, including PM, and transfer all these points here on the horizontal cutting plane line. Now project all these points in the front view, and from adjacent front view draw horizontal projectors, and you will get all those points and the true shape of the section. Draw label true shape of the section. All given dimensions you should insert in the drawing. So slant height is 75 mm in this problem. Cutting plane line makes angle 30 degrees. This inner circle is at distance 15 mm. It's given in the problem that cutting plane is 15 mm from axis. So this 15 mm circle radius we have shown here, and diameter of the base is 70 mm. So all given dimensions you must insert in the diagram. Now read this problem. You will find something new in this problem. Of course, I have given you a hint of this case. Read the problem. A cone of base diameter 50 mm and height 55 mm has its base in HP and axis vertical. So again, it's a very straightforward position. It's a very obvious position of the cone. It is cut by a cutting plane in such a way that true shape of section is a parabola with base 40 mm. Read the statement once again. It is cut by a cutting plane in such a way that true shape of the section is a parabola with base 40 mm. Draw sectional front view, sectional top view, and true shape of the section. Okay. Now very important thing here. We don't know position of cutting plane. Instead in this problem we are given true shape of base. So knowing true shape of the section, not base of course, true shape of the section, by knowing true shape of the section, we are going to locate the cutting plane. So now you are going to study how to locate cutting plane line for given true shape of the section. Obviously, very first step is to Draw front view and top view of the cone. Axis is vertical, so true shape of base appears in the top view. Axis given, so for apex, measure vertically 55 millimeters. If side view is not asked, you need not draw side view. Read problem carefully again. Last statement, draw sectional front view, sectional top view, and true shape of the section. Side view is not asked. And if it is asked, you should complete the side view also. At this stage, don't make any single line dark. Now, how to locate cutting plane for the parabola of base 40 millimeters? Now listen, in the same video, in example number 2, I explained to you that base of parabola is line UV in the top view. So for base 40 millimeters, you must have line UV in the top view, 40 millimeters long. So how to do that? Try to understand. Have you realized 20 millimeters and 20 millimeters symmetrically we have measured, and we have transferred those points on the circular base. So here it is point U, here it is point V, and this is that line UV, that is base of parabola, which is 40 millimeters long. Now in the top view, U and V are here. To transfer U and V in the front view. So this is how, by drawing vertical projector, we have transferred U and V in the front view. Of course, U and V are on the base. So in front view, we have transferred U and V on the base. So these are those 2 points, U dash and V dash. Section is a parabola, and that cutting plane must intersect the cone at this point. So you should draw a cutting plane line parallel to end generator because it is a parabola. To set roller with the end generator, roll it and draw a line parallel to end generator through points U and V. And this is how we have located the cutting plane. After locating the cutting plane, you should follow the procedure in problem number 2. That is, divide circle in 8 parts. Those are all 8 generators in the top view. Draw those 8 generators in the front view. Label points of intersection of cutting plane with letter cutting plane and generators with letter B. Transfer all those points. Get a parabola here. Of course, this is not true shape of the parabola. Make cutting plane line parallel to XY line and just follow the procedure. Now I'm not going to repeat the procedure here again. Now check this problem. A cone of base diameter 50 millimeter and height 55 millimeter has its base in the HP and axis vertical. It is cut by a cutting plane in such a way that true shape of the section is a parabola. Again, true shape of the section is parabola. So we are sure that cutting plane line is a parallel to end generator in the front view. So it is a true shape of the section is parabola with axis 40 millimeters. Last problem, it was base given, and here it is given axis. So how to locate cutting plane for parabola with axis 40 millimeter? That is what we'll study now. As usual, draw front view and top view of the cone. Now, how to locate the cutting plane? We are sure that cutting plane line is parallel to end generator, but exactly where it is. Try to understand the procedure. Take 40 millimeter length in compass, and from this corner of the front view, draw an intersecting arc on end generator on the right side. Now through this point of intersection, draw cutting plane line parallel to this end generator. Check. Draw the cutting plane line. Now let's read this example. A cone of base diameter 50 and height 55 millimeter has its base in HP and axis vertical. So obvious position. It is cut by a cutting plane in such a way that true shape of the section is an ellipse with major axis 35 millimeters. True shape of the section is an ellipse with major axis 35 millimeters. Draw sectional front view, sectional top view, and true shape of the section. So draw position of the solid. Look at midpoint of the axis. Set scale at the midpoint of the axis and use a trial and error method so that, watch carefully here, so that you get exactly 35 millimeter overlap here on the front view of the cone. Yes, here it is, say 35 millimeters. So this position of cutting plane line you should identify by trial and error method. And this is the cutting plane that gives you ellipse with major axis 35 millimeter. So in this video we have solved problem number 1. Follow the procedure and you will get front view, top view, side view and true shape of the section. Now read this problem. A cone of base diameter 50 millimeter and height 55 millimeter has its base in the HP and axis vertical. It is cut by a cutting plane in such a way that true shape of the section is a hyperbola with base 45 millimeter and axis 35 millimeter. Draw sectional front view, sectional top view and true shape of the section. So now here it is a hyperbola. Section is a hyperbola. So that means angle made by cutting plane line must be greater than angle made by end generator. First thing, draw views of the solid in given position. Measure base 40 millimeters. Base is a line UV on the true shape of base. So that line UV must be of length 40 millimeters. So this is how we measure that 40 millimeters on the base. Now transfer UV in the front view. This point is U dash and also V dash. Now through U dash V dash cutting plane line must pass. But it is not a parabola. So we are not going to draw cutting plane line parallel to end generator. In compass, take distance 35 millimeters and U dash V dash as a center. Try to understand. Now use compass, radius as 35 millimeter and center as U dash V dash. You cut the boundary generator in this manner. Now cutting plane is passing through U dash V dash and also through this corner. This distance, that is overlap of cutting plane line on front view, this distance is a 35. So when you make this cutting plane line parallel to XY line to draw true shape of base, what will get? Hyperbola of base 40 millimeter and axis 35 millimeters. Now let's read this problem. A cone of base diameter 50 millimeters and height 55 millimeter has its base in HP and axis vertical. Same position for the cone. It is cut by a cutting plane in such a way that true shape of the section is an isosceles triangle with base 40 millimeters. Isosceles triangle. Draw sectional front view, sectional top view and true shape of the section. This is first step. Draw views of object in given position. Now base of true shape is 40 millimeter. True shape of section is triangle, has base 40 millimeter. So base means that line UV that should appear in the top view as a vertical line. So this is how, like earlier few problems, we have located a line UV in the top view, transfer it in the front view. Here you will get U dash V dash. Now remember, cutting plane line must pass through U dash V dash in the front view. But then how will you get a triangle? Remember, triangle has 3 corners. So where is that third corner? U and V are the 2 corners. How will you get the third corner? So simple, cutting plane line must pass through the apex. When cutting plane passes through the apex, you get an isosceles triangle. So this is how you locate the cutting plane, and as usual you proceed, you will get true shape of section and isosceles triangle with base 40 millimeters. Now let's read this problem. A cone of base diameter 50, height 55 millimeter. Listen, all this from problem number 4 to problem number 9. I've used the same dimensions for the cone. Problem number 4 to problem number 9. What we are studying is how to locate cutting plane line for given section, given true shape of the section. So draw views of the cone in given position. It is cut by a cutting plane in such a way that true shape of the section is hyperbola with axis 40 millimeters. Draw sectional front view, sectional top view and true shape of the section. What is the true shape of the section? Axis 40 millimeters. So axis you get in the front view and base you get in the top view. Here base is not given. So only thing what we are going to manage is axis 40 millimeter. So we can draw cutting plane vertical. After all, for hyperbola, angle of cutting plane must be greater than angle of end generator. So if we draw cutting plane line vertically, then of course it will be a hyperbola, because angle of cutting plane line will be more than end generator. So let's do that. So measure 40 millimeter, transfer that point on end generator, and through this point you draw a vertical cutting plane line. Now the section will be a hyperbola of axis 40 millimeters. Here are points U dash and V dash. Cutting plane line intersects base. Of course, there will be 8 generators, and you will mark the points of intersection of cutting plane line and those generators with letter P. Remaining procedure is the same like all other problems on cones we have solved. Again, here something very important. If you transfer U dash V dash in the top view, so here it is point U, here it is point V, and the cutting plane passing through U and V. Check here, cutting plane is vertical, and any plane which is vertical appears line in the top view. So cutting plane has appeared a line in the front view as well as in the top view. So section is not available in the front view or in the top view. You will get section in the side view. Just follow the regular procedure and complete section on side view. Here, for side view, observer is watching from left side. So portion nearer to observer is removed. So make this portion dark. Observer is watching from left side. So make this portion dark. Section will not appear in front view or in the top view. Section will be a line in the front view as well as a line in the top view, because cutting plane is vertical and therefore it is a top line in the top view. Now from these two lines of representing cutting plane, we should realize that cutting plane is perpendicular to VP as well as perpendicular to HP. That means the cutting plane is parallel to side plane or profile plane. So you will get, as usual, section in the side view. Just follow our regular procedure. UV, label this point of intersection of generator and cutting plane. Here label this point of intersection of cutting plane and generator, and so on. And transfer these points in the side view. And you will get that hyperbola in the side view. Now how to draw true shape of the section? So remember, no extra work is required here to find a true shape. The reason is cutting plane line is already parallel to PP, profile plane, and therefore true shape of the section you will directly get in the side view. So no extra work is required here to draw true shape of the section. I think we have solved enough number of problems on cones. Thank you for watching this video. I'll meet you soon in my next video. Bye bye.